Welcome to Physics 2 Lab offered online. My name is George Manuchero and I will be your course instructor. To begin with, log on to fsw.instructure.com using your portal username and password. I'm going to use my username. This will take you to the Canvas dashboard. Click on your course name. Now, I'm going to click on Physics 2048L, which is not your course now, but anyway. Now, that takes you to the home page of your course. The home page contains a welcome message, an introduction video, that's what you're watching now. You have a video on how to make a good Word document with diagrams and symbols and so on. So watch this to learn how to write a good lab report. And then you have a video on graphing on Excel. This is a very important skill and you must watch this video and learn how to make a good graph on Excel and show on the graph how the slope of the graph is measured and reported with the correct unit. In some cases, it may be useful to learn how to make multiple graphs. In other words, if you have one graph made and already saved, you can actually save a lot of time using that same graph and doing another graph. All right, so watch that also. Next item is the syllabus. Click on this link, or you can click on the syllabus link from the toolbar on the left. Download the attached syllabus and read it completely. One of the most important requirements of this course is that you must have access to Word and Excel. Office 365 is available free for students and you can download and install that by clicking on to this link. Once all that is done, what you need to do is go to discussion and access the attendance verification and make a posting confirming that you have read the syllabus and watched the introduction video. Once that is done, it is time to access the course schedule, the lab schedule. Click on class schedules and it takes you to all the available labs that you are required to do this semester. Click on lab 1. You have two important items there. One is the lab document. Access that, open the Word document and read it completely. Now you understand why it is important for you to have Word installed on your computer. The next item is the data video. You need to watch this data video in order to access the data and to know the details of how to do the lab. Let me now explain to you how to write a good lab report. Now, these are some of the guidelines for writing lab reports. The first item is objective of the experiment. Write a statement or a sentence on what you aim to do in this lab. Now, do not copy from the manual. I have given you an objective. Well, that is the objective of the experiment. But instead of copying it, write it in your own words. Second, give a list of equipment that you use for this experiment. It is very important because this is an online lab and you must be familiar with what equipment I used for doing this lab. The third is give a summary of the theory of the experiment. Give a brief theoretical background for the experiment. This should include the equation for the experiment. Every experiment has an important equation. Now, for example, let's say the equation is the frequency equal to f equal to, say, 2 pi square root T over m. Now, that is the equation that guides the experiment. Now, in the experiment, you will be measuring certain things. In other words, you will be varying a quantity, and when one quantity is changed, you will be measuring another quantity. Now, we call them variables. Now, in this case, you change T. T stands for the tension on the wire, and F stands for the frequency of vibration of the wire. When tension is changed, the frequency changes as well. Therefore, T is the independent variable and F is the dependent variable. Now, you don't have to write it here, but you have to make a statement on that later on. The next item in the report is a short description of the method of the experiment. Now, I have described the method in the lab manual. Again, do not copy my instructions. What I have given you are instructions. For example, I would say measure the mass of the cylinder, and that is an instruction. In your report, you must write the mass of the cylinder was measured and recorded. If you look at the rubrics for grading the lab, you should know that 2 points will be available for the format of writing the lab report. If you do not use the right format, you will lose those 2 points. The next item in the lab report is interpretation. Now here, you need to write the equation in the y equal to mx form. Now, how do you write an equation like this in the y equal to mx form? The first thing you need to do is to identify the independent variable and the dependent variable. Now look at the equation y equal to mx. Now what this equation tells you is that when x changes, y changes proportionately. And if you draw a graph of y on the vertical axis and x on the horizontal axis, that graph will be a straight line through the origin. And if you measure the slope of the graph, what will that be? That would be m. In other words, the slope of the graph is the rate of change of y with respect to x, or it is delta y divided by delta x. delta y is the change in the value of y, delta x is the change in the value of x. Now, how do we write an equation like this in the y equal to mx form? Now, we have identified already that T, the tension, is the independent variable and F is the dependent variable. In other words, T is in the place of X and F is in the place of Y. We need to rewrite this equation in that form. Now, if you have an equation like this with a square root sign, I suggest that always square the equation to get rid of the square root sign. So if you do that, we get f squared equal to 4 pi squared, is that right? 4 pi squared times T divided by M. Now, don't confuse this M with this M in the y equal to mx form. That is the slope of the graph. In this case, this M is actually a mass value. And this is the quantity we may have to determine using the experiment. So, how is this equation written in the y equal to mx form? We have it already in that form. So, we got f squared equal to 4 pi squared divided by m times t. Now, if you look at this equation, f squared is in the place of y and t is in the place of x. What that tells you is that if you now draw a graph of f squared on the vertical axis and t on the horizontal axis, that graph will be a straight line. And what will be the slope of that graph? If you measure the slope of that graph, that quantity will be 4 pi squared over m. That's what it means. So we wrote the equation in the y equal to mx form. We identified the independent and dependent variable, and we did a graph of f squared on the y-axis and t on the x-axis, and we measured the slope. Now, write down the slope with correct unit. How do you know the unit of the slope? Now, remember, I'm going to just draw it here. Now, on the y-axis, you have f squared. The unit of frequency is hertz. And so f squared has the unit hertz squared. Yes. And tension is the force. And what's the unit of force? Newton. Therefore, what is the unit of slope? It is hertz squared divided by Newton. Hertz squared divided by Newton, which we write it like this, Newton to the power of -1. So this is the unit of the slope. Remember, what's hertz? Hertz is per second. So this is the same as Newton to the power of -1 times per second is s to the power of -1. This is hertz squared, so s to the power of -2. That is the unit of the slope. I'm going to use just a number. Suppose the slope we measured is, say, 5. So the slope of the graph we got as 5 Newton to the -1, second to the -2. That's the unit of the slope. So I'm going to write it as m equal to, again, don't confuse between the slope m and the mass m. Alright, what's the next step? The next step is calculation and result. Write down the slope with the correct unit now. So I say I have slope equal to, what did we use? 5 Newton to the -1, second to the -2. Then set the measured slope equal to the slope expression. What is the slope expression we had earlier? Well, the equation was this: f squared equal to 4 pi squared over m times t. Now, this is the slope expression. This is the slope of the graph for this particular graph. And this value, the value of this expression is this. This is what we measured from the graph. So you must come here and say 4 pi squared over m equal to 5 Newton to the -1, second to the -2. Now, the aim of the experiment, the objective of the experiment in this case, was to measure this m. This is called the mass per unit length of the wire we used. So, from this expression, calculate a value of m and write it with correct unit. So, what is m equal to? M is 4 pi squared divided by 5 Newton to the -1, second to the -2, and I think that's about 7.9. Now, what you get is 7.9 Newton second squared. If you can show that Newton second squared is the same as kilogram meter, you can earn 1 extra credit point. The next item in the report is sources of error. Identify some of the possible errors in the experiment and tell me the possible ways of minimizing those errors. And finally, every lab comes with a set of questions, and they will be mostly problem solving, and you need to solve the given problems giving all explanations for each step. It is not enough to write an equation and get an answer. You've got to tell me why you wrote that equation, why that equation is going to be used in here. So the explanation is very important. All right, and that's how your lab report should look like. And once the report is done, you can upload it to be graded.